The topic I shall be discussing is using Excel for descriptive and inferential relationships. There are two widely used statistical tools to determine magnitude of relationship or association between an independent or explanatory variable and a dependent variable, and the appropriate test of significance of the relationship. If the measure of the pair of variables is cardinal, or in simple terms, can be averaged, such as weight, cost, score, and quantity, Pearson R and t-test of R are used. When the measure of the variable is nominal or categorical, which means cannot be averaged, such as sex, color, preferred type of music, type of respondent, and favorite foods. Chi-square based measures of association and chi-square test are used. Pearson R and t-test of R. Pearson R represents the extent to which the same individual respondent, object, or subject occupies the same relative position on two variables. It shows how close the trend between two sets of data from the explanatory independent variables is. If the data are ex post facto, the relationship will not prove causation. If the data came from a non-probability sample or from a population, it is not appropriate to proceed to inferential analysis. If the data are probability, a test of significance of the relationship could follow. Let us consider this case. For the consecutive weeks 1 to 10, the price and demand for sugar each week are shown in the data in the next template. For your hands-on activity, open an Excel sheet and encode the dataset. Type in D2 R equals and click your pointer or cursor in C2 where the value of R shall appear. This is the Excel sheet with the dataset. After that, you click Formulas, click More Functions, click Statistical, click Pearson, and this array box appears. Type A2 colon A11 in array 1. Type B2 colon B11 in array 2. They are the ranges of the values. Click OK. And R equals negative 0.98896 will appear in D2. That is actually the measure of the magnitude of association from our sample. Assuming that the 10 pairs of the price and demand are probability samples, and assuming further that they were appropriately computed from a population of 1,000, we can infer that the magnitude of relationship from the sample R equals negative 0.98896 is significant or would more likely be observed in the population if the following conditions are satisfied. If the absolute value of the computed t is greater than the absolute value of the critical t, the relationship is significant, or the magnitude of relationship observed in the sample of 10 would more likely be observed in the population of 1,000. Otherwise, such magnitude observed in the sample would more likely not be observed or would more likely be zero in the population. To solve for the value of the computed t using Excel, let us go back to the Excel sheet where R has been computed. And we program the formula for the computed t value on the same sheet. In D4, type R. In D5, R squared. In D6, 1 minus R squared. In D7, small n. In D8, n minus 2. In D10, square root of 1 minus R squared divided by n minus 2. In D11, R slash square root of 1 minus R squared slash n minus 2. The computed value of t is solved. It is negative 18.8765. To determine the value of the critical t, we need to specify our alpha, and we assume it to be 0.05. Since the problem no significant relationship is two-tailed, we get the half of alpha, which is 0.025. Our degrees of freedom, n is equal to 10 minus 2, is equal to 8. So that is our degrees of freedom, 8. We shall solve for our critical t using the values of 0.025 as our alpha now and 8 as our degrees of freedom. In an Excel box, say A1, type ABS, open parentheses, t.inv, open parentheses, 0.025, 8, close parentheses, and the critical t value of 2.306 shall appear. You can also trace the value in a t distribution table by crossing 8 under degrees of freedom and 0.025 under alpha equals 0.025. The solution is also 2.306. Let us now look into the mathematical relationship between the absolute values of the computed and critical t's. Since the absolute value of the computed t, which is 18.875, is greater than the absolute value of the critical t, which is 2.306, the relationship is significant, or the magnitude of relationship observed in the sample of 10, which is negative 0.98896, would more likely be observed in the population of 1,000. Inasmuch as the relationship from the sample is significant, it could be applied to the entire population in the findings, conclusions, and recommendations of the study, and not delimited to the sample only. Let us proceed to the chi-square based measures of association and chi-square test. For the magnitude of association, we have phi coefficient. You look at the formula and you will note that it requires the computed chi-square value. We also have the formula for Kramer's V, and similarly, the formula requires the value of the computed chi-square. The computed chi-square is sum of the square of OF minus EF divided by EF, where OF is the observed frequency and EF is the expected frequency. EF is equal to rows total times columns total divided by grand total. Let us assume we conducted a study if the type of respondent is associated to one's preferred type of music, and the collected data are shown below. We call this the table of observed frequencies. We shall calculate the columns total and the rows total. We now have calculated the totals of all the rows and all the columns. We shall use the rows totals, columns totals, and the grand total in the table of observed frequencies to calculate for our table of expected frequencies, where for each box of observed frequency, a corresponding box for expected frequency shall be determined. We go back to the formula of expected frequency, which is the rows total times columns total divided by the grand total of the observed frequency. In the student rock cell B9, type equals B5 asterisk F2 slash F5. In the standby hip hop box F11, type equals E5 asterisk F4 slash F5, where you come up with the values 96.612 and 89.1803 respectively. If you repeat the procedure in all boxes, you shall arrive at our complete table of expected frequencies. Let us identify the boxes where we placed observed and expected frequencies, because we will be getting for each pair the difference. Box 1 with 100 observed and 96.612 expected. Box 2 with 50 and 70.6011 until box 12 with 100 and 104.918. We shall now prepare a parallel table for the sum of the square of OF minus EF divided by EF at B13 as our label, and start at B14 for the computations. In B14, type equals open parentheses B2 minus B9 close parentheses caret 2 slash B9, and continue the process until box is 16, where you will type equals open parenthesis E4 minus E11 close parenthesis caret 2 slash F14 or F11. For the computation of phi, encode 23.3675 in bit 22, 915 in bit 23. Type in bit 24 equals B22 slash B23, and type in B25 equals B24 caret 0.5 to get eventually the value of phi equals 0.15981. Assuming that our sample size of 915 is a probability sample, we can now know if the phi value of 0.15981 would more likely be observed in the population the sample represents or is significant by applying the inferential chi-square test. The chi-square test in Excel shall have level of significance alpha as the computed output from the observed and expected frequencies. Hence, in the concerned Excel sheet, click E13, where the computed level of significance or alpha shall appear. So, on the sheet, you click Formulas, click More Functions, click Statistical, and click chi-sq test. The box for actual and expected data will appear. The actual range of frequencies is B2 colon E4. Encode it in the actual range array. The expected range is B9 colon E11. Encode it in the expected range. Then you click OK. If the level of significance alpha is greater than 0.05, accept the null hypothesis of no significant dependence or no significant association. If the level of significance alpha is less than or equal to 0.05, reject the null hypothesis of no significant dependence or no significant association, and accept the alternative hypothesis of significant dependence or significant association. Since the computed level of significance, which appears on the Excel sheet, is equal to 0.0068, which is less than 0.05, we reject the null hypothesis of no significant association and accept the alternative hypothesis of significant association. This means that the value of phi, which is 0.15981, although very weak in magnitude, observed in the sample is significant or would more likely be observed in the population. So today, my students and fellow researchers, I hope you have learned something about the use of Excel in determining the magnitude of relationship or association through Pearson R or phi coefficient, and test of significance through t-test of R or chi-square test. Thank you for viewing and listening.